It is now time to shift gears and to turn back in our book back to lesson 9.1. So once again, in unit 8, we worked on different formulas for area of certain types of polygons. And then we continued over into unit 9, still using area. So we skipped this lesson because we wanted to continue on with just using our formulas for area and find the area of different three-dimensional shapes. Now, we're going to go back to lesson 9.1 at the beginning of this unit because we're going to use it. So now in unit 9, we're going to go from the idea of our three-dimensional shapes, and we're going to be able to find the volume. So in here, we're going to talk about the rectangular prism. But once we get through this and we take our test for unit 9, we also need to learn how to find the volume of triangular prisms as well as cylinders. So we'll get into those lessons as some extra work, probably in success period here before too long. But we want to look at the idea of what we just did in the last 3 lessons in Unit 9, and that was finding the surface area by using nets of three-dimensional shapes. But now we're going to be taking, instead of finding the surface area, now we're going to talk about those three-dimensional shapes. And we're going to see how much does it take to fill it up. That's what volume is. How much will it take to fill up that shape completely? So now the question becomes, how do we do volume? And some of you remember right away because you did this in 5th grade. It's 5th grade standard. Hopefully it's review. And then as we get into triangular prisms and cylinders and we find their volumes, then we can just add on to our base knowledge. But what some people don't do is they don't look at what you're actually being asked to do. They just say, well, I know I have to multiply 3 things and I'm done. Well, what you're actually doing mathematically is you are finding the area of the base, and then you're just multiplying it by the height. The formula is length times width times height. But let's look at what that means when it comes to volume. So when I have my rectangular prism and I find the area of the base, so I have my 3 times my 2.4, right? So area of a parallelogram is base times height. Since it's a three-dimensional shape, they give them different labels of length and width, but they're still going to be located in the same location to find the area of that parallelogram. I have the base, the bottom line, the height, the one that's perpendicular to it. So when I multiply those together, I get 2.4 times 3, and 3 times 4 is 12. Put down my 2, carry my addition of 1. 3 times 2 is 6, plus 1 is 7. 1 decimal space tells me to move over from right to left 1 time. So the area of my base of this rectangular prism is 7.2. But now I want to fill it up. I want to know what the volume is. So I'm going to multiply one more thing by that answer. If I was just finding the area of that base, it'd be 7.2 square meters. But I need to fill it up now. I want to know my height. So I take my 7.2 times the height, and I end up with 2 times 2, which is 4, and 2 times 7, which is 14. Once again, 1 decimal space, so I move from right to left 1 time. So what I'm finding is that my volume, how much does it take to fill it up to the top? It's going to take 14.4. Now, once again, area, it's a square label, but this is volume. And we have a square label in area because we're multiplying 2 different things with the same label. In volume, we're multiplying 3 different things with the same label. Since I'm multiplying by 3 items with the same label, then I know that my label has to show that there's 3 there. That's what we call a cubic unit or a cubic measurement. So volume is always going to have that superfix, that raised 3, just like area has the superfix 2. Right? So cubic meters is how we would say that, but we put the m with the floating 3 or the exponent of 3, because once again, that's telling me I multiplied m times m times m for my measurement of my unit. As the book says, when we're doing volume, we're always going to have a cubic unit for our measurement. All right, so if I can do this information, then my formula that I'm going to use each and every time is simply going to be that volume is equal to length times width times height. It doesn't matter how big, tall, fat, skinny the rectangular prism is, we're going to follow the pattern of length times width times height. So let's look at our examples in which we have, right? So this example, which I want you to work through, then we have 3 different measurements. We have our length, we have our width, we have our height. I've once again tried to color code them for you on the slideshow, even though they're going to print out in black and white on your paper. So if I find just the base measurement for the area of the base, then I do my 5 times 3. And 5 times 3 is going to give me 15. But then I always have to turn around and multiply it by the height. And when I multiply 15 times 3, then I get 45. So I have a measurement of 45 for my volume. But what's the label? There aren't any labels there. Well, if they ask you to find volume and they don't give you a label, then you just have to name it, cubic units, right? So units to the 3rd power. So if they don't give you a label, make sure you include one. So let's look at the next one. I want you to work with me. Notice we have mixed numbers, therefore we have fractions. Do we have to do it in fractions? Yes, because it gives you fractions. Because on NWEA in a couple weeks, you have to be able to do fractions. And on the iLearn next month, you have to be able to do fractions. So we will constantly review fractions and decimals as we continue to move forward. So we're going to be finding volume of this rectangular prism, which is length times width times height. Anytime I have a formula, I want to plug in the numbers that I know in the correct locations. So when I do that, then I know I can't multiply mixed numbers and whole numbers and I have to have them all in fraction form. So let's start with 2.5. If I have 2.5 and I need to make it an improper fraction, once again, I start at the bottom. I do 2 times 2, which is 4, plus 1 is 5, and I keep my denominator of 2. So I know that my length is 5/2. My 3, well, that'd be a whole number of 3, but I want to put it over 1 because it has to be in fraction form. And then the 1.5 for my height, then I'm going to, once again, start at the bottom, multiply and add. So 2 times 1 is 2, plus 1 is 3, and keep my denominator of 2. So then I have 3 over 2. Now, if I can cross reduce, I would cross reduce, but all I have are even numbers on the bottom and odd numbers on the top. So there isn't anything in cross reduce. So how do I multiply fractions? Well, I multiply across. When I do my denominator, 2 times 1 is 2 times 2 is 4. I would suggest when you're multiplying across on the top that you just kind of do a little bit of extra work and add the answer after the first 2, such as this. 5 times 3 is 15. Then you have 15 times 3, and that gives you a numerator of 45. Is that going to be my answer? Absolutely not, because we don't leave them as improper fractions. So I'm going to take my top number, goes inside the division box, divide by the bottom number. 4 goes into 4 one time, which is 4. I bring down my 5, and 4 goes into 5 one time, which is 4, with a remainder of 1. Once again, now I'm going to make it a mixed number. My remainder is always my numerator. My divisor is always my denominator. So I find out that the volume of this particular rectangular prism is 11 1/4 what? Well, when I look at the straight measurements they give me, it's inches, and I'm multiplying 3 measurements with the measurement of inches, so it has to be cubic inches. And that's my answer. Are you remembering this from last year? Hopefully you are. So now we kind of had a word problem set up and talking about sugar cubes and the size of sugar cubes. And please don't worry about any of that. What I want you to do is find the volume of this box that's labeled sugar cubes. Right? So if I'm finding the volume of this box, then I'm looking at volume is equal to length times width times height, always and forever. When I look at what I'm multiplying then, I see that I have some whole numbers and mixed numbers, none of which I can use the way they are. They have to be in fraction form. No, it does not matter if it's improper fractions. So my length is this 3.5. So I'm going to take my 3.5. Once again, just like the previous problem, let's start at the bottom. I'm going to multiply and add. 3 times 2 is 6. 6 plus 1 is 7. I keep my denominator of 2. So I know I'm going to use 7/2 for my length. Now we had 1.5 on the previous question, right? And we found out that 1 1/2 is going to be 2 times 1 is 2 plus 1 is 3. So we have 3/2, and that's our width. My height is a whole number of 6, but once again, I can't have whole numbers and multiply fractions with it. So I have to change that into a fraction as well. Now, when I'm multiplying fractions, how do I do it? I just multiply across. So I have 2 times 1, which is 4. And then I have 7 times 1, and that's 21. And 21 times 6, that gives me 126. Now, what I want to show you, once again, I don't like working with bigger numbers. Anytime I'm doing math and working on my answer keys and stuff, I will always reduce if I can because I prefer to work with smaller numbers because there's less likely of a chance that I'll make a mistake. So if I do that same math, I want to cross reduce what I can. Notice there is an even number in the denominator as well as the numerator. So I'm going to reduce one of the twos, and it doesn't matter which one you use, but I'm going to reduce the 1, 2 with the 6. So 2 goes into 2 one time, and 2 goes into 6 3 times. Now I'm reduced as much as I possibly can. I want to multiply across. So if I have 2 times 1, now I have a denominator of 2. If I do 7 times 1, once again it's 21, and then 21 times 3 is going to be 63. Now, when I divide, what I would end up at the top is going to be a little different than the bottom. The whole number would be the same, but the fraction wouldn't be. The reason I cross reduce is because in the end, I have to remember to cross reduce if I divide 126 by 4. But either way is correct. I'm going to do the 63 divided by 2. 2 will go into 6 3 times because 3 times 2 is 6. There's nothing left over. I bring down my 3, and 2 goes into 3 one time. That gives me 2 and a remainder of 1. So I end up with 1 as my numerator and 2 as my denominator. Now, if I was actually dividing in the top problem with the 126 over 4 and you divided, you should have ended up with 31 and 2/4. Well, 2/4, once you reduce your fraction, would have given you 1/2. So either way, we end up with 31 and 1/2. 31 and 1/2 what? Well, I'm multiplying inches by inches by inches. So I have 3 inches, cubic inches, inches to the 3rd power. That's my answer. I'm just multiplying length times width times height each and every time. But then I have things like decimals. So I'm going to do this one with you. And once again, if I'm going too fast, get the notes down, pause, rewind, rewatch, listen, and focus on what I'm saying so you know the steps. But since this is our first decimal in this lesson, I'm going to do it with you. Still going to use the same formula because we're finding volume. Length times width times height. When I look at my length and width, I have 5.5. I have a width of 3, and then I have a height of 15.1. So if I'm multiplying all those together, then once again, I need to do my order of operations. I got to go from left to right. So 15 times, or 15.5, excuse me, times 3. Well, 3 times 5 is 15. Carry my addition of 1. 3 times 5 is 15 plus 1 is 16. There's one decimal position, so I move from right to left one time. So now I have 16.5. But then I have to multiply that answer by the 15.1. So now I've got 3 different digits that I have to multiply by. 1 times 5 is 5, 1 times 6 is 6, and 1 times 1 is 1. Oh, that's right. 1 times any number is just that number, and they stay in the same order. That's easy enough. What about the 5? Well, that's my second number. And therefore, my second number tells me to bring down 1 0. And now I can multiply by my 5. And 5 times 5 is 25. Carry my addition of 2. 5 times 6 is 30 plus 2 is 32. Put down my 2, carry my addition of 3. 5 times 1 is 5 plus 3, and that's 8. Now I have a 1, which once again is easy to multiply, but I have to remember that that is my third number. So my third number tells me to bring down 2 zeros. And then I can put the 165, making sure everything lines up from right to left, and then I'm good to do my adding. 5 and 0 is 5. 6 and 5 is 11. Put down my 1, carry my addition of 1. 5, 2, 1, and 1, that's 9. 8 and 6 is 14. Put down my 4, carry my addition of 1. And 1 and 1 is 2. How many decimal spaces do I have in my math problem? Well, that's 2. So I'm going to move from right to left 2 times. So we found that our volume is 249 and 1500ths, or 0.15. And what's my label? There are 3 inches in my units, so I know it's going to be cubic inches. Circle my answer, and then I'm good to go. We got the hang of this? I hope so, because now we switch gears and we do something a little different. Still going to use my formula for volume is equal to length times width times height. But now we're finding the missing dimensions, and you're going to have 2 of these on your practice work tonight. I still do the same thing that we've done all along ever since we started messing with letters known as algebra. I plug in the numbers that I know for the labels that I know. When I see that I have volume V is equal to 60 cubic feet, well, I'm going to start building my formula by plugging in the numbers, right? I don't know my height, so that tells me that's going to be my missing variable that I have to solve using my algebra steps. So I start filling in my formula. 60 is equal to, well, 60 is equal to, the length is 5, and the width is 3, and I don't know my height. So I'm just going to represent that with my variable, which is a letter, h. Now I have to do the math that I do have. I have 5 times 3. Well, that's 15. I bring everything else down. Now what am I going to do? Algebra. Have to get my variable alone. So I have to do my opposite function. And then I have to do it on the opposite side. We've been doing that for 4 months now. So if I'm multiplying by 15, then the opposite function is divide by 15. And once again, it just cancels out, leaving my variable alone, which is what I need. Then I go to the opposite side. I'm going to divide 60 by 15. Once again, the top number goes inside the division box, and 15 goes into 60 4 equal times, because that is 60. So what I'm finding is that my measurement is 4, and it's a height. Now, keep in mind, we aren't finding volume, right? We're finding a straight edge measurement, which is the height. And if it's a straight edge measurement, I just use the straight measurement. I don't have any exponent. So I'm finding that my height is equal to 4 feet. We got that? How about we try another one? All right, so now we have this one. We're still going to find the same information. They don't give me a V is equal to. However, when I'm reading the information, I see that it is there in the word problem. So if I know that my volume is 94.5 cubic inches, then that's got to be my volume. And once again, I'm looking for my height. So I'm going to go through the same process that I just did on the previous question. I'm going to plug in for my volume. I'm going to plug in for my length, which is 6. I'm going to plug in for my height, which is 4, or excuse me, my width, which is 4.5. And then my variable h is going to stay for my height. Now we got to work with fractions and mixed numbers, right? We have to change both of them. So I take 2 times 94, I multiply, and then I add. 2 times 94 is 188, plus 1, 189. I keep my denominator of 2. So that's my volume, and I know that's going to be equal to, well, I have a 6, but I can't use whole numbers, so I put 6 over 1. But then I have to change my 4.5. Start at the bottom, multiply and add. 4 times 2 is 8, plus 1 is 9. Keep my denominator of 2. So now I have 9 halves, and then I'm just simply going to keep my h. I'm going to solve for my variable. So now I have fractions that I'm going to multiply. Notice on my fractions, I can reduce the 2 and the 6. So I want to do that because I, once again, prefer smaller numbers. So 2 goes into 2 one time, and 2 goes into 6 3 times. Now I'm just going to multiply those 2 across. So if I multiply those across, then I can see that 3 times 9 and 1 times 1. So I have a denominator of 1, and I have a numerator of 27. I'm going to keep my h. Notice I've kind of spaced some things out here because I have more steps to do. All right, now I have algebra. I'm multiplying by 27 over 1. I need to do my opposite function on the opposite side. Well, Mr. Barker, why aren't you just changing that to 27? I'm not changing that to 27 because I can see that I have a fraction still over on my left-hand side. And so I have to do work with fractions, so I'm going to keep it as 27 over 1. Well, if I'm multiplying by 27 over 1, then my opposite function is to divide by 27 over 1. That once again is going to cancel out, leave my h alone, which is my goal. So I'm going to go to my opposite side and divide by 27 over 1. And how do I do that? I can't, right? So we have to KFC it. So once again, KFC, the K tells me to keep my first fraction. I have 189 over 2. The F tells me to flip my second fraction. So I have 1 over 27 now. And then I change division to multiplication. Can I cross reduce? Well, I don't know if 27 goes into 189. So what I do is I pick up my handy dandy calculator and I type in 189 divided by 27 and I see if it gives me a whole number, and it does. Oh, thank goodness. Makes my life a lot easier. So 27 goes into 27 one time, and 27 goes into 189 7 times. Now what I'm left with is 7 over 2 times 1 over 1 is equal to h. So what I have is that h, my height, is equal to 7 over 2, or 7 halves. But I can't leave 7 halves, so I got to change my improper fraction into a mixed number. 2 goes into 7 3 times because that's 6 with a remainder of 1. I keep my denominator of 2. My numerator is 1. So I'm finding that I have 3.5, but 3.5 what? Well, once again, we're using inches. So I'm not going to cube it because I found a missing measurement. Therefore, it's the measurement of a straight edge on the rectangular prism. So it's going to be a straight measurement of inches. Notice there are 2 labels there. I need the inches and I need h is equal to. All right, so you do your work. That's one answer. Or 1 point, you do give me the correct answer. That's 2. You give me inches. That's 3. And then it's equal to h because I'm solving for h. That's 4. So don't miss points unless you really just mess something up. All right, so hopefully that's pretty easy, and it is review. So after this, then we'll come back to lesson 1.1 for day 2, take it a little bit further and work with word problems with a little bit harder of an assignment. But right now you have 5 questions, 3 that are pretty straightforward, finding the volume of the rectangular prisms, and then on the back you have 2 where you're going to solve for the missing measurement. If you need help and you have questions, please ask us because that's what we're here for.